So in this second lesson of Homework Packet 4.3, we're going to continue to look at polynomials. But instead of going from equation to graph, we're going to go from graph to equation. We'll see what we mean by that on the next slide. So what I have here is I have a polynomial equation already graphed. And notice the directions say that we're going to be writing an equation from the graph. So I've got a graph here of a polynomial, and my goal is to find out the equation y equals ... What is the equation that if I were to graph it would give me this polynomial? So that's where we're at right now. Now, it's actually a fairly easy process. If we remember, if I had a polynomial, and one of the very first things we did with graphing a polynomial was to factor it and find the x-intercept. So often we'd end up with something like maybe x times x plus 2 times x minus 6. And then we'd say from this I know that x equals 0, x equals negative 2, because negative 2 in here is what makes this 0. And then what makes this 0? A positive 6. So these would have been our x-intercepts. Our goal is to go backwards, because if we look at this graph, we can see where the x-intercepts already are. I see that my x-intercepts are at negative 3, 0, and positive 4. So the question is, can we go backwards? Can we go backwards instead of from a factor determining the x-intercept? Can I know the x-intercept and go backwards to the factor? And we can. So here's what this is going to look like. I've got y equals. Let's start with the 0. What do we know an x equals 0 always comes from? It always comes from an x at the very beginning of our factored equation. Let's then focus on this negative 3 right here. X equals negative 3. The question is, what is the factor that a solution of negative 3 comes from? And we remember that it's always opposite, so I'm going to think x plus 3. Because what would make x plus 3 0? By plugging negative 3 into it. So a negative 3 comes from a factor of x plus 3. We can use the same logic here for the x-intercept of 4. What would a solution or an x-intercept of 4 come from? What would the factor look like? And it would look like an x minus 4, because I plug a positive 4 in here to make this factor equal to 0. So what I have here now is I have a situation in which I've built an equation with each factor that gives me each of my x-intercepts over here. Last thing to do is to write this in standard form. So I'm going to go y equals, I'm going to distribute the x into this first term and get x squared plus 3x. And then the x minus 4 still here. Now remember, you don't take the x and give it to both terms. Not okay. You give it to the first term, and now that I have this new first term with the x distributed, this is what I distribute into the second term. So x squared times x is x to the third. X squared times negative 4, negative 4x squared. 3x times x is 3x squared. 3x times negative 4 is negative 12x. Cleaning this up gives me y equals x to the third. Let's see, negative 4 positive 3 would be a negative x squared minus 12x. So here is the equation that would have given me this graph that I started with. I do want to look at one more example because there's some intricacies that can appear in doing these problems that weren't present in the first problem that we did. So I've got another polynomial here, and I need to come up with an equation y equals for this. I see that my x-intercepts are at negative 5, now 0 and 2. This one is the interesting one because it doesn't actually go through at 0. What does it do? It bounces off 0. That's going to be treated a little differently. Okay? So going through and developing the factors for each of these, we know that if 0 is one of our x-intercepts, that we have an x in the front. However, because it bounces off, what do we know about the x-intercept of 0? We know that it has a multiplicity of 2, which means that it should be an x squared up front here. X squared again, because it bounces off, x equals 0 comes from x squared with a multiplicity of 2. And we learned in the previous video that when you have a multiplicity of 2, it doesn't actually go through that point, it simply touches that point. Now we've got negative 5 to deal with. That comes from an x plus 5, because a negative 5 would make that 0. And then the 2 here comes from an x minus 2, because a 2 in here for x would make that 0. Now, we're actually not done. There's one other small, interesting piece to this that we need to consider. If we look at the end behavior chart, where we looked at the up, up, down, 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 up, and up, down. I'm not sure if I did that exactly the way I did it in the other one, but you get the point. This one is down, down. If you look in your chart at down, down, what you'll notice is that the leading term has to have an even coefficient, and we will end up with an even coefficient, because x squared times another x is x to the third times another x is x to the fourth. But what you'll notice is that down, down comes from a leading coefficient that is negative, okay? Which means that we need a negative out front, negative x squared, in order to get it down, down. If we leave it as a positive x squared, it'll give us an equation that looks like this instead, the exact opposite reflected about the x-axis. So we need that negative here in order to make sure that it gives us the correct end behavior of down, down. So with that said, we can now work through the process of distributing here. So negative x squared into x plus 5 gives me negative x to the third minus 5x squared. So that's distributed into that first term. And then we have to multiply that by x minus 2. So negative x to the third times x is negative x to the fourth. There's our negative up front and an even exponent that gives us the end behavior of down, down. Okay. And then negative x to the third times negative 2 is positive 2x to the third. Negative 5x squared times x is negative 5x to the third. And negative 5x squared times negative 2 is positive 10x squared. Cleaning that up gives me y equals negative x to the fourth minus 3x squared by combining these two terms plus 10x squared. And there's the equation of this graph of a polynomial.